So, I hope it's working. They've changed the program a little bit. Law of cosines. And the way we're going to prove it or derive it is using a little coordinate algebra, coordinate geometry. So we set up a scalene triangle. Not necessarily a right triangle, not necessarily anything. And we'll label our vertexes A, B, C. Now just like normal, opposite sides are little a, little b, little c. So if this side is little c, the coordinate of point B is going to be c comma 0, because it's c units away from the origin. We're going to designate the point, the vertex c is just plain old xy, some point out in the coordinate system. First quadrant. And then A obviously is the origin 0, 0. Okay. So if we do that, then we can drop the altitude, call it h. Why not? Well, actually, we know what the altitude is. It's not h. What is the altitude? How long is that black dotted line? According to the picture. Should I start worrying now? Yeah. Why? I'm asking actually a very simple question, so don't think about it too much. Look at the picture and try to figure out how high is h. Okay, I'll give you another hint. How high is the vertex C? Y. It's the y coordinate, because y is always how high, x is always how far left and right. So this h in this terms is going to equal y. And the distance along this portion of the base segment is what? Another easy question. The height is y, and the width is x. From here to here is x units, because this coordinate is x comma y. So you go x units to the right, and you go y units up. So this distance has to be x. And why didn't that right? I'm having problems with this thing. Try this one. It's not doing that. I'm just not having fun with this. Why isn't this working? Oh, now it works. From here to here is x. And you think I had this all worked out before. Might have to call the company. Alright, so according to that triangle, the base being blue, the height being the black dotted line, and the hypotenuse over there, we can figure out something according to that angle. We can say that the cosine of that angle is equal to, do I want to do cosine? Yes. Well, cosine is what? Adjacent over hypotenuse. What's the length of this hypotenuse according to the vertexes?
AC, so that's why.
According to, remember how we labeled the opposite sides of a triangle?
Oh, B.
It would be little b. So this side is little b, and the adjacent is x. So you get cosine of A is x over b. Yeah, it's right. All right, the other thing we need is sine of A. So what is the sine of A? Y over b. All right. So we find, according to this one up here, that, what do I want to solve for? I think it's x. That x is equal to b cosine of A, And this one here, y is equal to b sine of a. So it's another way of describing that coordinate. B cosine a is the x-coordinate, b sine of a is the y-coordinate. Then we have some fun. If we're looking for this side, the length of this side, we can find it. It's not that hard. It is the distance between C and B, and we know the coordinates of both of those. So we set up a nice little distance formula. You all remember the distance formula, right? Or should I write it down? Write it down. You remember it? You remember it? Change in x squared plus change in y squared, all square rooted. Okay. So if I'm looking for a, that's going to equal the square root of the change in x between vertex C and vertex B, which would be x minus c. So you get x minus c all squared. And then the change in y would be y minus 0, better known as plain old y squared. And then we can expand it out. So this is, plus I don't like the square root, so I'm going to square both sides just to make life easier. I don't like square roots. So this becomes a squared is equal to, what's x minus c all squared?
X minus c.
All squared. You can't square root under square root because of the plus.
So x squared minus 2xc
No,
plus
cx
cx plus c squared.
plus y squared. Okay. And then the fun begins. We're going to use these substitutions here at the top. X equals b cosine a and y equals b sine a, and shove it into this thing. Remember I said most people hate this? Because it's just a wild algebra ride. So this becomes a squared is equal to x, which is b cosine a, but you're going to square it, so it becomes b squared cosine squared a. You have to square everything inside. Minus 2cx, so this becomes minus 2c times b cosine a, plus c squared, plus y squared. Now y is b sine a, so it'll be b squared sine squared a. Doesn't that look pretty? So, what do you want to do with that mess?
Combine like terms.
Is there any like terms to combine?
No.
Nope. What else do you think we can do to it? Do you see anything familiar in there? Maybe not even close to each other, but quite familiar from chapter 5. Identities.
Sine squared, cosine squared.
Sine squared and cosine squared, right? So if I can get these two next to each other, they're very similar, sine squared, cosine squared, but they also both have a b squared, right?
Oh.
So I can factor it out. Now if I factor out b squared, what's left behind? Well, sine squared plus cosine squared, which is equal to 1. Kind of cool, huh? So this becomes a squared. I'll write it all out. I'll move the sine squared to the front term, factor out the b squared. And I'll put things in alphabetical order too. We get that. So it's just a little rearrangement and factoring of that b squared. And we know that sine squared plus cosine squared of the same angle is equal to 1. Alright, so if it's equal to 1, this is going to have a b squared, it also has the c squared, and it has this weird term, negative 2bc cosine a. So finally I get to write a squared is equal to b squared plus c squared minus 2bc times cosine of angle a. And this is the law of cosine. Or as the book calls it, law of cosines.
Does the 1 just go away?
Well, it's 1 times b squared,
Oh, okay.
which is just b
Yeah.
squared. Now, I usually don't write the law of cosines this way. I like writing it in the Pythagorean setup. And the Pythagorean setup, put it up here, is c squared equals a squared plus b squared. That's the Pythagorean theorem. Now, to finish it off, how would I finish it off? That takes care of the 3 square terms. Then it's going to have this minus 2. What letters do I put there? Which one?
B and C.
A and B. Because if you look at this, this is B and C, B and C. So if I change it into a squared plus b squared, then this becomes 2ab. So you get 2 times ab cosine of what angle, what vertex?
C.
C. So if it's little c on one side of the formula, it's big C on the other side of the formula. This is the one I prefer to memorize. Yes, you have to memorize it. It's not that hard. It's Pythagorean theorem minus the 2 letters you heard, 2 times 2 letters and cosine of the opposite side. Now, if C is equal to 90 degrees, which is usually the right angle on a right triangle, C being, what's the cosine of pi over 2? 0. This whole term goes away and you get the Pythagorean theorem. So the Pythagorean theorem is actually a special case of law of cosines. Kind of weird, huh? So you could prove Pythagorean theorem using the law of cosines instead of the old. Did you ever prove Pythagorean theorem in high school?
No.
That's really sad. There's ways of doing it. There's actually several ways of doing it. This is one of them. All right, so for example, well, not for example, but what triangles does law of sines work on? Do you remember? I'll put it over here. If you have law of sines, what types of triangles does it work on?
Side angle side.
Side angle side?
Yeah.
Does it?
Side angle. Oh,
Side angle. Yeah, the bad one. Star that one. Does it work on side?
angle side.
Angle side.
Side angle side. Or angle side angle.
Angle side angle.
And that's
Now, the law of cosines is not going to work on any of those. Well, actually it could, but we try to leave those for law of sines. Law of cosines works on the other 2. Side, side, side. Best way to prove triangles are congruent is to know each one of the sides. And side angle side. And like the bottom 2 over there, it guarantees one triangle. Guarantees one triangle. So, for example, let's do side, which one's easier? Side angle side. So, we draw a triangle. I'll just label it. Here's A, here's B, here's C. And let's say we know this side is 5 inches, this side is 10 inches, and the angle in between them is 100 degrees. So you get that side angle side setup. Opposite of B, of course, is little b, so that's what we're going to be looking for, is little b. So the setup for law of cosines is going to be start with little b on this side of the formula. So this becomes b squared is equal to, what other letters are left? Well, a and c. So it becomes a squared plus c squared minus 2 ac cosine of angle b, big B. So the letters are interchangeable, you just have to keep the pattern going. Now, since we're looking for b squared, I'll leave that alone. What's a squared in this, or what's a in this case?
10.
It's the 10, it's opposite vertex. Now, if you mess that up, does it matter? Not really, because you'll eventually catch it. So the real a is the 10, so it's going to be 10 squared, plus, and then c would be opposite it is 5, minus 2 times 10 times 5 cosine of 100 degrees. And make sure your calculator's in degrees. Just type all that mess in. So you get b squared is equal to 142.36.
Yeah.
Oh, you didn't get that? Did you take the square root then already? Or?
Yeah.
Well, if you did, I'm getting there. Once you get down to b squared is equal to this mess, you have to, well, square root it.
Yeah, I didn't get that. I need square root.
You already did?
Yeah.
So what you get is final answer.
Error.
Great. How the heck did you get an error? Did you have a negative answer or something?
Yep.
Do it again. Let's see what you're typing in.
Oh, there it goes.
Okay. And then just square root it, and you should get 11.9, approximately. I highly suggest you use the approximate symbol when you start using your calculator to come up with decimal evaluations. It indicates that it's not the exact answer. Try to use equals for exact. You just have to type it in exactly the way it looks. Make sure your calculator's in degree mode.
I did. I got like negative 4.3.
You can't have negative. It gives you a guaranteed positive triangle. Let me see what you typed in.
Then when I multiplied it by the cosine of 100, that's when I got negative 4.
Minus 100. What?
Minus 20 times 10 times.
Type it in exactly the way it looks. Go literally 10 squared plus 5 squared minus 2 times 10 times 5 cosine of 100. You get it?
Mm-hmm.
555, but you'd be pushing buttons on that calculator. Did you get it? As quiet as you are. I know, you're drugged. Now, the other part of the problem is generally you're trying to solve the triangle. So you're trying to find all the possible sides. I'm only going to find one of them. Well, we already have the sides, but I mean the angles. So it's 11.9 inches. Don't forget your measurements in inches. What if I wanted to find, let's say, the measure of angle C? What if I wanted to find this measure up here? Measure of angle C. What would you do? Stare at it. Great.
Side angle stuff. Can you just do it again to find that?
You could do law of cosines again, but sometimes law of cosines is a pain in the butt, especially finding an angle. Do you have to use law of cosine? What other one is nicer?
Science.
Law of sines, much nicer. So if I'm looking for C, I would set it up as sine of angle C over
5.
5, its opposite side, is equal to, pick the angle that we already know guaranteed without a doubt,
Sine of B.
sine of B, which is sine of 100, over
11.9.
what we just found, the 11.9. And then, you know, you do your cross multiplication and all that fun stuff. Eventually you have to use, find a calculator, function,
Oh, inverse.
sine inverse, sine inverse. All right, go ahead, find me an answer. 'Cause I don't know how to do it. Of course I'm lying, but that's okay. Did you get it?
What?
Huh? I want to see. What's C equal to? Measure of angle C. multiply both sides by 5. You're going to sine inverse both sides, so you're typing into your calculator sine inverse of 5 sine of 100 divided by 11.9. And you should get 24.4. 24.4 degrees. So the measure of angle C is approximately 24.4 degrees. Awesome. How would you find angle A?
So it's 100 plus
180.
24.4.
Yeah, do the 180 thing instead of going back into one of those laws. Much easier. Just do a little subtraction. Woo, that's a law of cosines. Is that hard?
Yeah.
Oh, it's horrible. That's actually red. All right, how about new page?
Oh, you finally got it to work.
Yeah, I don't know. I think the batteries were dead in this thing. How about this one? For example, another picture of a triangle, ABC. Let's say we give you all the sides. Oh, by the way, if I give you any 3 measurements, do they always guarantee a triangle?
No. One is.
If I gave you 3 sticks, any 3 sticks, can you make a triangle out of those 3 sticks? Guaranteed without a doubt.
No.
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 Can it be like a flag?
No, a triangle.
Oh, no.
Where the ends of the sticks meet at the vertexes.
No.
Can you give me an example of one that wouldn't work?
100. 2 1s.
100 and 2 ones would never ever make a triangle because the base would be so long the 2 ones would never ever touch. So what is the basis of the longest side you can have? What determines the longest side you can have on a triangle? Mm-mm. That only works on right triangles. What has to be true about the 2 short sides compared to the long side?
That would be short.
Greater.
The sum of them has to be greater than the third side.
What do you mean?
So little sub-theorem that you should have known since like geometry back in high school. The sum of the 2 shortest sides has to be greater than third side. If you want a triangle, you have to. I gotta turn that off. You have to make sure that the sum of the 2 shorter sides has to be bigger than the third one. Because if it's not bigger, it's never going to form the tent. They'll just kind of open up and have a gap between them. So if their sum is bigger, then when you open it up, they actually form a nice vertex. So when you pick these sides, I'm just going to randomly pick them. I have to make sure that my 2 short numbers add up to be bigger than the third one. So if this is 4 and this is 5 and I make this one 8, is that going to work? If I have a 4, 5, 8 triangle?
Yeah.
Yeah, that would work. But if I have a 4, 5, 10 triangle,
No.
that's not going to work because 4 plus 5 is 9, which is smaller than 10. It has to be bigger. So I'm going to set this up as 4 meters, 5 meters, 8 meters, 8 meters. That'll work because 4 plus 5 is bigger than 8. So law of cosines in this case, you're trying to find one of your angles. So which angle do you want to find?
B.
Okay, let's go for B. So if we're looking for angle B, how would I set up my law of cosines?
B squared
B squared
equals A squared plus C squared. Wait, A squared plus C squared
Yeah.
minus 2AC cosine big B.
The one thing I hate about the law of cosines is if the c is here and then you have the start of cosine as a c, it sometimes gets lost. So I'm always careful to put a dot in between them. All right, and then fill in what you know. Do I know b?
Yes.
Yeah.
b is 8. So this is 8 squared is equal to, do I know a?
4.
Oh, and before where I said it didn't really matter about the a and the c over there, the a, b, and c over here is really important to get straight, because if you put the b on the wrong side, it messes up everything. A in this case is opposite of a, which is 5. C is opposite c, which would be 4, and then you just fill in the rest. 5, 4, and cosine of, I don't know what b is, so I'll just leave it there.
So you're gonna do that subtract.
Well, there's a couple tricks you can play. You want to play tricks? I like tricks because it shortens the work up. And one of the tricks is, if you want to solve for this cosine of b, and this term happens to be negative. So if I take this whole chunk and I move it to the right, it becomes positive. And if I take the 8 squared and move it to the other side, it becomes. So I just consider that taking these two pieces and flipping them. And it works out rather nicely. So on this side, you're going to get 2 times 5 times 4, which is 40. Yeah. So 40 cosine of angle B is equal to 5 squared plus 4 squared minus 8 squared. And it makes life a lot easier that way.
You got to divide it by 40.
Eventually. I'd rather you just crank that out as a number first. So what's 5 squared plus 4 squared minus 8 squared?
Negative something.
Negative something. Maybe. Possibly. It is.
Negative 23.
Negative
23.
23. Alright. So you get 40 cosine of b is equal to negative 23. Is that possible?
No.
Why?
What? Yeah, I guess.
You tell me. Is it possible?
Sure.
Sure. What can't be negative? The angle.
Yeah.
It's impossible to have a negative angle. Well, for triangles. In coordinate systems, yeah, you can have negative angles. It's just reverse wrap. But in triangles, they have to be positive. All right, how do I solve for cosine of b?
5 by 40.
Divide both sides by 40, so you get cosine of b is equal to negative 23/40ths. How do I get b by itself?
Inverse
Inverse.
cosine.
So the measure of angle b is going to equal cosine inverse of negative 23 over 40. What can you tell me about this angle before you type it in?
Too late.
What do you mean?
How big is it going to be? Is it going to be acute or obtuse?
Real big.
Small. I don't know.
You should know.
It's big.
How do you know?
I don't know.
Oh, come on. The information's all right here.
Small answer.
Why is it not an acute angle?
I don't know.
Because the ratio is
Small.
negative.
Oh.
And if it's a negative ratio, cosine inverse only works in the first and the...
Second.
And if it's in the second quadrant, it has to be
Big.
bigger than 90.
Oh, yeah.
Because it opens
Yeah.
up further. So I know that this is going to be greater than 90. What does it come out to be?
125.1.
So measure of angle B is approximately 125.1 degrees. What's nice about the law of cosines, unlike the law of sines, is you're guaranteed one answer. Guaranteed one answer. Where law of sines, you have the possibility of 0, 1, or 2 answers. So that's the one you have to be careful with. Law of cosines, you don't have to be careful with, other than the setup. All right, how would you find, let's say, measure angle C?
Could you do the whole thing all the way? I kind of like that.
When we talk about solving a triangle, you find everything. All the sides, all the angles.
No, I'm saying, could we use that formula again and just solve it for C?
You could, but this formula is not that nice compared to law of sines. Law of sines is much quicker to find things.
One.
So if I was going to find measure of angle C, number one, is it going to be bigger or smaller?
Smaller.
Is it the smallest angle or the second smallest angle?
The smallest.
It is absolutely the smallest. Why?
Because the side is the smallest.
The opposite side is the smallest side. So the smallest angle will always be across from the smallest side. So if we're going to look for C using the law of sines, you'd go sine of C over 4 is equal to, pick the angle that we know.
Sine
Well,
of 125.
we only have that one down there. So sine of 125.1
Over 8.
over 8. And then do the same thing that we did earlier. Move the 4 up, sine inverse both sides, so you get measure of angle C is equal to sine inverse of 4 sine 125.1 all over 8. Whatever the heck that comes out to be.
24.1.
And then to find the third angle, add those two together, subtract from 180. Isn't this nice? Law of sines, law of cosines. Really simple stuff.
Is that it?
Yeah, there's not much to these.
Seriously? You're done?
That's law of sines. Cosines, cosines, law of cosines. So, now I stop, and we go back